3, 2, 1, top, allumage et décollage.
This flight is a single payload mission performed by Vega. This 12th mission is aimed to inject in orbit the science platform Aeolus. The targeted orbit is a Sun-synchronous one. The roughly low altitude is 320 km for spacecraft measurement of wind profile across the atmosphere. The liftoff time is defined at 6 p.m. 20 minutes and 9 seconds in Kourou local time. The launcher total mass at liftoff will be 138 tons compared to the required spacecraft mass of 1,357 kg with an average thrust of 2,200 kN after the first stage PAT ignition. During the first phases of flight, the solid booster stages PAT 023 and 09 will be tracked by the ground station Galileo over a duration of 7 minutes. The last stage, integrating a liquid engine named AVUM, reached a transfer orbit after a first boost duration of 9 minutes. This boost will be tracked by Bermuda and Canadian Saint-Hubert ground stations. In order to make the SSO orbit circular, a shorter second boost less than 1 minute will occur under Australian Lunar Sphere ground station visibility after a long intermediate ballistic phase of 36 minutes. Mainly linked to spacecraft mission and its atmospheric laser Doppler instrument called ADM, the trajectory is constrained in attitude throughout the flight, and this such complex mission is one of the most appropriate for Vega system. On the targeted orbit reach, Aeolus will be released after 55 minutes of flight. After 1 Earth rotation, a third AVUM boost is foreseen over a duration of 2 minutes and ground tracked by Saint-Hubert in order to proceed the fourth stage direct re-entry. End of mission will occur after 1 hour and 50 minutes of flight.
We are nearing the end of this exciting launch campaign, which started about 2 months ago. On the 28th of June, the Aeolus satellite arrived in French Guiana by boat, which is quite uncommon for Arianespace launch campaigns. The choice to come by boat was made to avoid the pressure changes which occur during takeoff and landing of an airplane, and for which the payload is very sensitive. The satellite was transported to the S5 facilities at CSG the same day and was unpacked the day after. A fit check was performed to verify the interfaces between the satellite and the launch adapter. In this test, the air purge system was also checked. The purging system is introduced to keep the payload extremely clean, as the slightest contamination could impact the mission performance.
The contribution of Arianespace Payload, Environment and Interfaces Department to Aeolus project started well before the launch campaign. Indeed, this department is in charge to ensure the spacecraft qualification to Vega flight environment, to customize the flight adapter, which enable first to install the spacecraft on the launcher, then its good separations once the targeted orbit is reached. We are also in charge to verify the compatibility between this adapter and the satellite via different kind of compatibility checks called fit checks. Thus, for Aeolus, I participated in 2017 to separation tests and beginning of 2018 to the fit check, allowing to confirm the total compatibility, mechanical and electrical, of the two elements, adapter and satellite. For what concerns the launch campaign, the Payload Interface Technical Authority issues a technical specification to be respected during the different combined operations between spacecraft and upper part elements at the adapter and the ferry. These specifications enable to respect all the requirements of this equipment and of the satellite.
In the following weeks, the electrical testing on the satellite was performed and the preparations for the fueling were completed. In the S5B fueling hall, the satellite was filled with the monopropellant hydrazine, and next to this, the satellite was also filled with oxygen. The oxygen has no function in the propulsion system, but is used for in-orbit purging of the high-power lasers and the emission path optics. The oxygen purging is required to avoid any deposit of contamination, again to guarantee the extreme cleanliness of the payload. After the fueling operations, the combined operations phase was started with the integration of the Aeolus spacecraft on its flight adapter. After final checks and inspections, the fairing was integrated around the spacecraft, forming the so-called pack.
All along this combined phase, the technical authority worked in very close collaboration with the responsibles of operation, giving its technical support when needed and participating to the potential anomalies solving. The technical authority is also one of the spacecraft customer main contacts during the launch campaign, providing its support on technical topics.
The pack was transferred to the launch pad on the 8th of August and was integrated on the launch vehicle the day after. The dress rehearsal has been completed successfully from Jupiter 2, and the Aeolus spacecraft is ready to enter the final chronology towards the launch.
ESA is a faithful customer of Vega for Earth observation. Aeolus will come after Sentinel-2A and Sentinel-2B, launched with Vega in 2015 and 2017. As the first wind profiler in space, Aeolus is a challenging mission. It was supported for many years by highly motivated people, some of which attend the launch today. For them, it is the result of hard work and perseverance.
So the main purpose of this mission is really to provide wind profiles to weather forecasters, but also to climate research community in Europe, but also throughout the world. Aeolus is a core mission in the Earth Explorers program of the agency's Earth observation development. We have implemented that by a very new and revolutionary technique called wind Doppler LiDAR. It's based on a single instrument called Aladdin, and it is having a laser which shoots light into the atmosphere and then measure the Doppler shift of that light when it reflects back to the instrument, collecting the photons that are reflected from the atmosphere. We have encountered many problems in that development because it's the first one of the world. Nobody else has done it, so we had no reference to understand how problems could be solved. Nevertheless, we have done so, and we are here today with a fully tested, developed and tested instrument and satellite.
The Aeolus satellite is now ready for launch. It is enclosed in the Vega fairing and cooled in a continuous airflow. We at Arianespace, along with our partners Avio and ESA in its role of Vega Qualification Authority, are proud to serve the Aeolus mission.
This flight is a single payload mission performed by Vega. This 12th mission is aimed to inject in orbit a science plate from Aeolus. The targeted orbit is a Sun-synchronous one. The roughly low altitude is 320 km for spacecraft measurement of wind profile across atmosphere. The liftoff time is defined at 6 p.m. 20 minutes and 9 seconds in Kourou local time. The launcher total mass at liftoff will be 138 tons compared to the required spacecraft mass of 1,357 kilograms with an average thrust of 2,200 kilonewton after the first stage PAT ignition. During the first phases of flight, the solid booster stages PAT 023 and 09 will be tracked by the ground station Galileo over a duration of 7 minutes. The last stage, integrating a liquid engine named AVUM, reached a transfer orbit after a first boost duration of 9 minutes. This boost will be tracked by Bermuda and Canadian Saint-Hubert ground stations. In order to make the SSO orbit circular, a shorter second boost less than 1 minute will occur under Australian Lunar Sphere ground station visibility after a long intermediate ballistic phase of 36 minutes. Mainly linked to spacecraft mission 8 atmospheric laser Doppler instrument called ADM, the trajectory is constrained in attitude throughout the flight, and this such complex mission is one of the most appropriate for Vega system. On the targeted orbit reach, Aeolus will be released after 55 minutes of flight. After 1 Earth rotation, a third AVUM boost is foreseen over a duration of 2 minutes and ground tracked by Saint-Hubert in order to proceed the fourth stage direct re-entry. End of mission will occur after 1 hour and 50 minutes of flight.
Allumage et décollage.
Greetings.